Hi, hi Rajendra. Hello everyone. A very good morning and a very good afternoon and a good evening to all of them in the webinar. The so thanks for joining this webinar. This is conducted to Edureka. The objective of today's webinar is going to be on just breathing yourself through the world of data science, just digesting something as to what's happening and what it is and all that about. And so you're going to be trying to just understand what is the data mining, some of the stages within the data mining. One of the most popular software that is, taken over the world, I should say, in the recent days, recent years, which its existence is not new. It's been there for a very long time, and it is, there have been precursors to that. But what is taken out of breeze and more a favorable software, so to say, is the R. So we're going to just quickly looking into what is this and what's a data scientist. We're trying to understand the context behind this all, right? So we're not going to be talking about how this word is being coined, but what involves in a data science, what needs to be, what is the need of a data scientist, right? So what is the basic need behind this so-called data scientist? And finally, we will be looking into the roles and responsibilities of a data scientist. So the immediate question after understanding what is the need for it, you might understand, so what kind of role can a data scientist play and what kind of roles are the data scientists playing essentially, right? So these are the many questions you might have it in your mind. And finally, we'll be wrapping it up, this webinar, with a example with a sentimental analysis, which is widely and very favorable analysis for scholars, right, in the computer world, in the natural language processing world, and any because of the more sporadic information. So when you look at the unstructured data, which is what kind of changed many things in the recent times, in the recent world after the involvement of, or rather the boom of the so-called internet, so-called the social media, sites, social engagement, collaboration sites such as Google and Facebook, LinkedIn, Twitters, and all that actually. Right. Okay. That being said, data is prevalent everywhere, and everybody actually, is playing around with the data, and every organization is not new to it, where they've been either consuming or they've been storing data for a very, very long time. And though it's so funny to say, as it says from this particular comic, so to speak, like you can see that if you take a recent example of where the places where the these analytics or the big data, or whatever you call it, as big data analytical, big data insights, data science, any term it may be, you can see that the data, which is fundamentally what it is, right? Has shaped up the world. And one such example is like, believe it or not, Germany not only won the World Cup, football World Cup, but underneath it, there was data science in it, right? There are a lot of research, a lot of data science and analytical and algorithms were applied to mine through the past data and understand not just the German players, also the opponents, also the way they had the opponents play, how did they in various scenarios over a period of time, et cetera, and all that. So you can see how the impact is not just for the company which runs the business, it also, for the opponents or the competitors as well. So that's what data has done, or that's what the data science and the analytics has done over a period of time. And that's what it is doing now as such. Now, just as it says about, like, what I just talked about is nothing but a sports analytics, right? That's the application of it, right? Now, in the sense, the vertical, as I said, right? So some of the scenarios, if we talk about where does it come into the picture, like where does it apply, right? Where and what essentially is required, uh, that's something which I could say it's a data science application, right? Now, if we look at the basic terminology, as Wikipedia would say, right? So data science is nothing but the study of the generalized extraction of knowledge from data, and the key word is science, right? That's a statement. Now, if you look at what does it mean is data plus science. So essentially, it's the knowledge the insight which you try to understand or grasp out from the data using the science per se, right? When you say the science, essentially we're talking about science in the nature of whether it may be a science out from physics, science out from mathematics, science from uh, machines, etc., etc., and all that. So it's nothing but an state where you process something. Essentially, process here means processing the data, right? Analyzing the data, extracting the knowledge out of this data and insights, and all these are basically done through things such as machine learning. And machine learning itself is where the artificial intelligence are being a part of appliances to the machine learning as such. It's a state where your machine tries to understand your data by itself and starts to produce you the results. Now, when it comes to the processing part, we know that where we are in a world where the lots and lots of data, masses of data which is being stored, and this is essentially where Hadoop comes into the picture. And you can take a note of this link as part of the Edureka blog, where you can see a lot of conversation happening in terms of Hadoop, where it provides you a great point of node for you to actually, or a repository for you to gain knowledge on big data and Hadoop as such. Now, so that essentially means three things: storing, organizing, and integrating huge amount of unstructured data is where your applications of data science are. And processing and analyzing this data, right? And extracting the knowledge, insights, and why you want to do this all? You want to predict the future from the data, right? Okay, Jason has a question. Is it necessary to look into data? Some problem looks very evident. That is true. Now, a problem looks evident, but still it goes beyond that, right? Though the problem is evident, there are not proper solutions. The solutions may be there, but there are situations where you wanted to actually come up with various options to that. It may not be one solution, right? What if there are 10 solutions to it, right? So essentially, we're talking about a case wherever we are talking about there is an evidence towards a problem. It may be straightforward evident, but when it comes to finding an root cause behind it, predicting even before the problem occurs, right? Even you stop the problem to occur, right? What if you stop the problem to occur, or what if you minimize the problems to occur? So those are the things which you're talking about, essentially deriving out from the data, right? Say for example, right? If say for example, as you said, in terms of the problem is evident, and let's say for example, you stop at a bus stop. Okay, anywhere in the industry, are there examples of places where people have not used data and things have worked out? Well, actually speaking, people are not using data, right? And have things are worked out? Things are being working out, yes. Say for an example, right? let's say, for example, you have a bus and a bus stop, right? And the buses have been coming, people have been boarding in, and you've been going into the right destination where you have, right? But the what we call here a problem here is the population here, right? You've been going to your destination, that's all fine, and it's always crowded. It's all a problem. Yes, it's a known problem. So what? People give birth, and there's always going to be an more and more population, and the bus is not enough for you. Now you're living with the problem, right? We are not doing anything with that, right? Things have worked out, right? The industry, the so-called the industry that generates, or the organization runs this so-called buses, all it's all working out. Now, what if tomorrow comes up with why you need big data and analytics and data science is, you know what, there'll be just as you saw on the first slide, there's going to be somebody who's looking into this data if you don't do it, and he's going to come up with a much more a bigger bus, or a bus which can actually do some innovative stuff, like, or maybe he's going to introduce something called a double decker bus. Now what happens, essentially he takes the guy who has been running this business for a very long time out of the competition, right? And why is that so? That is because he was just living with what it is. And he was just taking the information as how many people were there at a given point of time, or etc., etc. And he's been accumulating this information and not done anything with that. And he's been living with that. Now, what happens? That is where, like somebody like who a competitor would come and knock you out if you don't react to it. And to do react to it, right? Essentially, what you would do is do this data science, right? Or so-called analytics, right? Thanks, I do get it is required, but like Steve Jobs, he went with his gut feeling, right? So sometimes data is overrated. How do I avoid overloading data? How do I avoid over-analysis of data? Now, there's a lot of things which involves in terms of data science and all that, right? So again, I would disagree when you said Steve Jobs just went with his gut feeling, right? So there was a bit of, obviously, the information which was all involved in it. There could be, the guys, marketing analytics guys who were there, and other things. And believe me or not, the just an FYI for you, right? He believed that the customers did not know what they want. No, I mean, he was right. So, see, he was aware of the information, but then he believed that, see, he started to institute his idea into your mind, right? He started to say, this is how the industry needs to be. This is what it needs to be. So it's not that he did not know what is happening around, right? uh, I remember I've been reading some of the blogs, right? So, for example, like there are a lot of organization, including in mine and myself. People do analyze the surveys, right? The customer surveys, and Amazon takes a survey, or there are so many organizations who take a survey and analyze the survey so that they can improve the customer experience, right? So what happens is, like, I remember going through this blog, or going through this, not even blog, it was an article in the Forrester for that matter, right? Where it talked about the cost surveys specifically. And one gentleman in that blog, in that forum, or he commented saying that I have been using iPhone for so and so years, and I never have come up across a stage where Apple have ever surveyed me, you know and the reason why we're talking about is that because they tap all the usages of the customer. They know what is happening, how is this, and etc., etc., and all that. So essentially the products have been designed in such a way that there was not much of a need where they need to take a survey upon, right? And there could be still a survey, not necessarily through the customer directly, but indirectly, like for example, like what NSA is doing, right? In the same manner. Okay. Yaneshwara Rao. And there's nothing like overdoing with the analytics. Yeah, analytics could go wrong. not with the algorithms what you choose and use, but rather with like taking the wrong problem to solve, right? If you take the wrong problem, and that's how it could happen. And also, what I would advise is, since it's a webinar, we will be running short of it. I would rather have your questions hold it, and I'm going to take it at the end of the session, actually, right? So I'm going to take a note of your questions. Thanks for the questions, though we'll be taking a note of it at the end of it. Uh, so, so I'm going to take a note of all your questions, Jason, and we'll be looking into these questions. So let's go through this webinar and then take this question. So quickly, there was one question from Yaneshwar. I'm just going to answer also that. Yaneshwar, Prashant, I'm going to answer your question quite later. Apologize for that. So, so that being said, that's the appliances or applications of data science, where you store, organize, integrate your data, and process these data, try to extract knowledge about it and insights, and try to predict the future from that, right? Now, if we look at how is it done, so basically there are so many life cycles like KDD, which is nothing but knowledge discovery and data mining. There's a website called KDD Nuggets. The person who actually started us off. We can, Prashant, I don't see there are any audio issues. I hope others do not have any audio issues. Please check your audio at your end. Right. So there is quite a few techniques or life cycle methodology which are available for data science, and as far as the on the data mining as such. So one such popular one is called as KDD, knowledge discovery and data mining. And this came out from the person who runs that KDD Nuggets website as such. So when you look at the flow or the stages of your data science or data mining, is first is where you start to collect the data. It is where, like, in other words, to say, once you have a data, you have to start selecting the appropriate attributes and appropriate things which is required from the various amount of data which you collected, right? So first process is selection of the right information within the data. Now, once you start doing that, the selection of data, the next thing is to start processing, like targeting the right information within the data, right? Which is basically is what you call it as pre-processing. In other words, where essentially, like, there are certain things where you have to, like, in terms of there are so many words so many jargons are there in the data science, and such as, like, cleansing, data cleansing, data munging, and all those things which are there. That also is, those are the things which you call as pre-processing of your data, right? And the next step essentially is the pre-processed data is where you actually start to do some transformation of that. Now, the transformations is where the data wrangling, and again, like, there's data where, like, for example, if you take an age and the distribution of the age as such, right? It could be so that there are a lot of missing values in that, right? So there could be a lot of missing values in your age. Now, essentially, where you actually transform this into, you handle these missing values, right? So the NAs and other things. So that's the place where the pre-processing of the data being transformed into a form where you can start look into this data, into this transformed data, which is your next step, where you this transformed data is taken, and you start to understand this data, right? Understand this data and try to understand this data through exploration, right? Where some exploration analysis happens on top of your data, is where you apply your hypothesis or other techniques essentially on top of that above, and essentially where you actually start to do your chi-f test, t-test, chi-square test, and all those things on top of this data, either doing exploratory or descriptive analysis on top of this, And then you start to get the patterns out of it, understand the patterns out of this, and start to have this data transformed and mined in such a way that you can start apply some model on top of this normalized data, where the data is like, and is where you start to take those test data, and then apply your model on top of this test data. And then once you do it is where you start to evaluate your data, right? So that's where the last step happens, where your evaluation happens on top of this model which you built on those transformed and mined data, essentially on the sample data, and then apply it to your entire population or such. And the knowledge what you gain is where it's either a prediction or prescriptive, right? So that will be the end thing which you realize out of all this whole KDD process in terms of your data mining as such, right? So those are the steps involved, or the stages in your analytical life cycle, analytical world, right? Where first you select your data, right? And then you target the right thing within the data for your process, pre-process those data. Once you pre-process the data, you transform this data, right, into something which is understandable, something which you can start working on. Then you start mining into this data, because the data initially is going to be an ugly data. So you need to make this ugly data into a better shape, so that you can start looking into this data which can make some meaning out of it, right? So once you understand the basic stuff by exploring this data, is where you start to get the patterns out of it and build your own model, right? And then, identify if there is a pattern at all over there, right? Once you do that, you build it, is where you realize something called predictions or prescriptions. Would transformation also involve applying business logic? Essentially, your whole process of this from the start to end is where it's business logic. When you say business logic, I would slightly change the word business logic here. There's nothing like an if-else loop statement or something like that traditionally as you are used to when you build a web-based application. This is more of understanding from the data, right? If I give you an example, let's say I have the height of the students in a class, right? Now, what essentially you try to do is, once you know what is the average height of it, then the next step is, let's say there is a new student who joins, right? Now, let me tell you something. Your system should be able to tell you this student who comes in, first, it should predict whether the student is going to be a male or a female. If it is a male, then tell me what is his height. If it is a female, tell me what is her height, right? Now, when you identify that this is the average height, and this is the average height of a male or a female in your class, and then when you build the model, when you use the model to build that using a certain algorithm, that is what I would call it as a business logic in the world of your web-based development or anything. Now, even going beyond that, if you don't call it as even a business logic, now once you know that whether this person is going to be inside as a male or a female, right? Then what do you do next? Is what you would do it in whether I should give an admission or not, and then you would have some kind of criteria for that to give an admission or not, right? That is where your usual business logic in your organization or in your company or in a university is applied. So that is the last thing you do, is in terms of applications, like for example, student application and admissions, right? So once you know that this is a male or a female and this is the average height, should I admit this person into this class, right? Based on this particular, so that's where your business logic would come. Okay, so there is nothing called business logic, but if you want to really term it, it comes more at your web world where you have a front-end system, etc., etc., and all that. Okay. Now, So the next thing is we looked at what is a data science is, what the world terms it as, what are the things which are involved in the data science, what kind of applications do you think is a data scientist? We know the flow, what it involves to build a data science or an analytical solution, so to speak. At the end, what do you realize? Predictions or prescriptions, right? Prescriptions are where, like for example, I said whether the person who's going to join our this class, whether it's going to be a male or a female, or what will be their height. That's what you predict. But prescriptions are something where you say, right, it is good to have a person who's of this height and who's a male for this particular class. That is when you're going to have a better admission rate. That is what is called prescription. Now your end result, and that is where the executives, that is where the organizations all look into you when you do a data science project or a data science task or from a data scientist. A prescriptive analysis is what is that I said now, right? When you stop at place where you say the person is going to join or where this class is going to be male and is going to be of this height, that is what is called as prediction. You predict the future based on the past data, such as your height and the previous height from this particular class for this year, for the last 50 years, etc., and all that. All right. Now, to do this programmatically, right, what would you need? Right? At this point of time, there are many tool sets. What we're looking at is one of the most popular language called R. So what is R? R is a programming language, and R is a programming language. It is built by a statisticians for statisticians, right? And you primarily use it, and it is an environment for statistical analysis, right? Now, what I'm looking at in this screenshot is a basic R, a standard R. Now there is an IDE for that, which is what I'm going to demonstrate it, which is called as an IDEs, integrated development environment, which are nothing but R Studio, right? So this is just an R console, which you're seeing at, and when you execute that binary essentially in a Windows, it's just going to show you up with a command prompt kind of, it's a shell rather to say, right? And R is a software which you use also for data analysis, has powerful visualization packages and all that. All right. I mean, for example, if you actually look at the thing which is there in the screenshot, they're doing nothing but this is a package which is used for a library which is used for visualization. ggplot, very powerful, and essentially they are installing it, invoking it, and then just a simple random number generating it, right? A normal distributed random number, and they're putting it into the X and Y, binding them based on column-based binding, putting it in a new observation or a variable, just simply plotting it. And then this line is so simple, nothing but, out of one single line, they're applying an advanced algorithm called k-means clustering, right? So they're just doing a k-means simply by just writing one single line. And essentially, if I wanted to look at this particular k-means data observation, I'm just going to simply look into the structure of this k-means, so which actually tells you the number of clusters, the centroids, the total sum of squares, within sum of squares, total within sum of squares, between sum of squares, and the size of it actually, right? The size of the clusters and all that. So the various other attributes which you can find of that. It's so simple. In one single line, you can just write a complex algorithm, derive what. So there are a lot of other works which is involved, like is to one, the knowledge of telling what is the right algorithm for this particular business problem, right? And then when you wanted to apply or write it, and you do it through R, it's going to be so easy, right? So that is what actually kind of demonstrate it shows as such actually, right? Now, another example of data visualization, I said it has a very powerful data visualization. What exactly you're looking here is a plot that represents, which by just looking at, you can just tell we are looking at a Canada map here, right? Or something of that sort, right? I mean, so we're looking at the Toronto map rather actually, right? And and what it is actually showing as is all the traffic signals, right, is what we are looking at. It's overrate, and it pulls all this information right out from the data, right? And the entire structure of the city comes in. So it's like that powerful we are talking about in terms of the. So you can just see in the previous slide, we just saw that we're applying a advanced algorithm. Clustering is what we did. And here we're looking at an advanced visualization, right? So that is the power of this language, and it's so easy. In fact, for that matter, if you look at the way this thing is built, it will be again one single line is what it takes for you to build this actually. All right. So R has that capability as well, very powerful visualization as well, and so that's about the R. And again, coming back to the topic, the data science, what is it, right? So it's a common term where people say, right? So, okay, if you take an example of, we all know Flipkart, oh, sorry, we all know, like the Netflix, right? And we all know Amazon movies. Google also has stats movies and all that. And we all know the IMDb. So there are a lot of movie recommendations out there, right? So now you can see these movie recommendations they want to improve, and they get when you compare it, they kind of looks more compare one to the other. A lot of movies are recommendations where it looks much better. That reason being they get more and more better is because the more and more data. So algorithm is best only when you have more data to it, right? So the more data usually beats better algorithm. It's not that a better algorithm makes better results, right? So the algorithm to be better, you need more data, right? Because we're talking about, always remember that, again, more data necessarily does not mean that all the data are good data, right? It could be that you have a terabyte of data and 500 rows. It doesn't mean that every information is valuable for you. It could be so that only half of it is valuable. But when we say more data, we also mean the fact that more relevant data, right? So let's say, for example, NSA kind of uses click streams, right? In terms of understanding what you've been doing when you get into a browser, right? The behavior, or maybe even organizations have started to use the click streams nowadays, right? To understand the behavior of a customer in a website, actually, right? And so it essentially kind of store every stroke of the customer, every move within the page, right? Now, all this is not going to necessarily help you. Only certain things, like when he actually, clicks a particular button, or changes the font, is what is going to be relevant for you, so that you understand the person whom we are. The reason why he does it is because he's not comfortable with the font size of it, right? Or he does the maximization because it doesn't automatically happen, right? So that's what we're talking about. So no matter how your algorithm is, it can be just simply the right data makes your algorithm sophisticated, looks sophisticated. That's what happens with the recommendation engines as well. Prasanna's question is, can we embed the scripting language like Python for data extraction from social media in R? Yes, simple as that. That's the power of R. It has every plugin recommendations. Yeah, I mean every plugin and all that. So you can use, you have something called R Python, which you can use it and simply use that within your R. Yes is the answer. Now, so when we look at what constitutes this data science, what are the things which are involved, right? What does it take to understand or involves in terms of job and tasks of a data science, right? We were talking about many things. If you remember the first slide, we talked about storing massive volume of data, right? And then we are talked about processing this data and analyzing this data and taking meaning out of it and predicting something. And also in the terms of the stage, we looked at it and we said we were trying to explore this data, right? So what, so if you talked about all these various things which I just mentioned, is processing this data. So we know that the data comes in many ways in these days, and we're talking essentially about the big data, right? So, and storing and processing this data involves something called is all part of something computations, and which is nothing but data engineering is what we're talking about, right? Some various sources, desperate data as such, and all that, right? Now, um to store this data and process this data, we're talking about massive parallel processings or distributed computing, and all that is basically what is required. Massive RAMs and processors and infrastructure is what we are essentially talking about, right? It, a data scientist or a data science involvement is there in the advanced computing as well, right? Now, in addition to these two things, once you process, store, right, this data and extract this data and analyze this data is where you start to apply certain knowledge and mathematical statistics as such. So there is an advanced need for and usage of statistics, mathematics as such, right? And to put this all together in a very good perspective, right, is the fact of knowing what you are doing, right? So what is your business? What is the one big question you wanted to answer? What is the one big problem you want to solve? Just the way I talked about, as long as you determine the fact you wanted to solve the problem in school admission or the class admission, or you know developing a new type of bus, if that is what you wanted to solve a problem, that is solve the problem of the population by developing a new type of bus. And how do you do it? Essentially, to do that, you got to have something called domain expertise. As long as you are expert in that particular domain, this whole data science is not going to help, because that is where the root, that is where you start, is to apply, because you're not going to go anywhere at all when you actually start this whole data science journey. So in addition to the data engineering, advanced computing, statistics, and all that, what is most important is the domain expertise, right? So that being said, one big piece, whom do you do all this for, right? So though you do this, though you have the knowledge of statistics, domain experience, data engineering, advanced computing, at the end of the day, if you look at what we saw in the earlier, right, the last thing is you gain this knowledge, you build an insight. Now where does this insight go, right? Who's consuming this insight, who's using it, and what they're using it for? There's going to be a guy who's sitting on top of the organization, there's going to be a guy who's sitting and saying, "Echo, you know what, I make the call," right? So there are these executives who are the one who have to look at, and they have to be you know they have to agree, they have to take the bite, right? If they have to take the bite, they have to agree to it, and you have to sell off to them. You have to put it in the way they understand this. So you take this statistics, what we're looking at, back to him and saying, "Hey, I found this. Now, can you implement this?" Right? I predicted this. Can you implement? You know what? He will not agree to it. Okay, so you predicted, so what? Right? Now, that is where the most important piece comes into the picture in the whole data science, which is called visualization, right? So human takes many things so easily when you visualize it. Images, all this thing what makes human even more, right? So if you look at a number, and if you, the way he conceives the number, how he conceives, not by looking at the number, not by knowing what it is, what does it mean, by looking at the image of the number, right? So visualization is the key part, because that is where at the end of the day all your data science work are consumed, or rather is fruitful, because that is what an executive looks at it and says, "Ah, yeah, I see the breakthrough now, and I see what is going to happen, right? I understand what is happening and what we need to do," right? So visualization tells a lot of story, and you tell the story through visualization. So these are the key components of your data science. So data engineering is where when you say storage and process, your Hadoop comes into the picture, Again, Hadoop being a distributed computing is where your advanced computing comes into the picture, whether it may be Hadoop, Spark, Storm, or whatever it may be. And uh, the type of domain which you work in, that is the industry knowledge, automobile, sports, right? Finance, banking and finance, FMCG, right? Arrow, whatever it may be, right? As long as you have that kind of knowledge, you'll not be able to solve that problem, right? And applying a certain techniques, algorithm, right? You need to know that, right? And finally, you need to take the results and put it in a form where it is understandable as somebody who's going to make the decision out of it. And if you look at the type of demand in terms of the skill set, we talked about by looking at the previous picture, right? You can understand the various type of things which are involved, right? One, we're talking about one person who is like diversified and all this, right? You know, those days we used to say jack of all, master of none, right? So here it's not the case. You got to be jack of all and master of everything. That's what the big data kind of starts to emphasize on, right? Talking about a guy good in visualization, and talking about a guy who's good in data engineering, talking about a guy who's good in building algorithms. And you're talking about a guy who's very good in various domains. Talking about a guy who's good in advanced computing, right? And also, you know, it's not just you put the visualization, you're going to passive that guy who's sitting, the executive, and say, you know, he needs to buy in, right? So you're the guy who's going to be communicating it. So you should be, the end of the day, you should be able to communicate back, articulate what you did actually, right? So this is what Gardner says, big data creates big jobs, 4.4 million IT jobs globally. And there's a link towards that. And this is the report of the big data skills gap. Two-thirds of big data skills requirements are not met due to lack of skilled professional. That way you can see a lot of universities and all that have started, and even they have started part of their curriculum itself, right? Their education fundamentals itself. Only one-third is what we are looking at of the, you know, is being supplied out. And again, if you look at the type of vacancies we're talking about, so now what has happened is this big data and data science started to create various types of jobs. It's not that you're going to be a guy who's going to always build an algorithm, right? Building an algorithm could be one person, right? And being a data engineer, that is the storage, processing this could be one person's job, right? And the guy who works in building this visualization could be like, so those are the situations where a person who's a BI, essentially he develops his skill to the next stage where he mines to the big data and starts to visualize from that, right? So from reporting, he goes to advanced visualization, right? A guy who's been doing a data warehousing goes from working from a traditional DB2 to all the way to Hadoop storage, right? A guy who's been building a web-based architecture that goes on to build and distributed computing architecture, right? A guy who's been just a quantitative analyst goes on to become an analyst who's even beyond that. I mean, like, it's still whatever algorithm you built and all that, right? Data science or nothing but, if you, in my words, I always feel that this is something which has been there earlier, even it is there, something which is what, like, you know, companies like Morgan Stanley or, you know, JP Morgan or banking sectors, all they've been using this and what they called as quantitative analysts. Maybe they've not been mining through massive data set, but that is what they do. That's the biggest difference as actually with the involvement of various different tool sets. All right, so that's the difference from those days to now. And the big data itself is nothing but new appliances, new applications, rather than and new appliances, applications, and old problems, so to speak, right? So this is a trend which we are looking at the data scientists, right? As far as job trends is concerned, where they work. There's a pretty old slide, but you can still. I don't think it would have drifted here. It's still, you know, gone something like this also probably, right? So we looked at the component, right? So when we talk about data science, when we talk about the you know, putting the components such as data engineering, advanced computing, and the statistics and all those and visualization, and other words, in a much more you know, like a broader term, so to speak, or in terms of aligning it more in terms of the tools and techniques for data engineering, advanced computing, visualization, And for statistic analytics, the way how we can put it is, for all your data engineering needs, the data architecture involves tools such as Hadoop. For your processing, storage, when it comes to analyzing, right? Analyzing, exploring it, right? When you connect the dots, when it comes to your data, like data mining, right? The stages of analytics in terms of your selecting your data, pre-processing your data, transforming your data, all these things you essentially do it through your analytics tools such as R, right? And then when you build your model, that is identify the pattern, right, and evaluate it, is where you apply your machine learnings, where you apply your actual algorithms. On a big data scale, you use something like as Mahout or MLlib or whatever it is, and there are so many other things, like, they're just listed Mahout here. There are so many others as well, actually. And finally, to visualize it, you either use R or use other, web data visualization tools. I mean, it could be in a programming language, it could be D3.js, or it could be a Tableau or anything else for that matter, actually. So for the big data appliances, there's so many different tools as such, actually, right? And so I mean, just to so when I check that, this is just something which I just want to quickly share in the same way. Like, so this is an example of the ecosystem, right? If this is for the though it is for the kind of the Hadoop ecosystems or something which you can say, but still, when it comes to data acquisition, like, processing or putting your data, these are the various vendors what we are talking about, right? And when you talk about data mashups or data, like transformations and all those things in the big data world, right? So these are the data providers, so to speak, right? These are the various organizations in terms of your NoSQL or any data storage and all those things. When it comes to this, is like they also have this, because like CEP is nothing but complex event processing, or nothing but your streaming data, right? Where, like when the data comes as in stream. And when it comes to analytics, like, just as there's so many other tool sets, right? But are being the open source in comparison to the other as we speak. Again, for data visualizations, there are so many other tools which are there for data visualization. I mean, sorry, data visualizations in terms of, like, advanced computing, right? When we talked about advanced computing, we are talking about these data visualizations tools and organizations such. And when it comes to the BI tools, right, whether it may be data visualizations or something even more as that, and other business process management and actions as such, as these are various vendors we're talking about. So consider this as a vendor landscape what we're looking at for various data science jobs or data science life cycle, as we just saw it, right? In terms of data acquisitions or data transformations, pre-processing, validations, and all those things as such, right? Now, what do you want to talk about this, right? Why do you want to talk about Hadoop and R together, right? So the reason being that we know Hadoop is become a synonymous when you talk about big data, right? When you talk about storing big data, right? And when you talk about analytics, we talked about R, right? So putting it all both this together, how it is happening. So there's a company called Revolution Analytics. They were the one who came up with a set of bunch of libraries package, so to speak. It's an open source which is available in through CRAN, and they call it as R-Hadoop. And so this R-Hadoop fundamentally has three packages. The RMR is for the MapReduce. Fundamentally, they apply the MapReduce technique computation paradigm, which is applied in RMR package and library. The R-HDFS helps to manipulate, access the HDFS from R, and again R-HBase is the same for accessing and providing other things such as data retrieval, data storage to HBase from R. Uh, right, the HBase data management from that. So that's Hadoop and R together. So Revolution Analytics is the organization who came up with this R-Hadoop, which essentially does that. And they do have the commercial version of R as well, in the sense that essentially they have many, what they have essentially done is like, they have the parallel processing and other things and packages catering to the enterprise as such, in addition to the open source, and they do the supports and all that actually, right? And they have quite a few algorithms which are implemented, which does the parallel processing in Hadoop. And this Revolution Analytics is now a Microsoft company, right? And machine learning. There was a question on machine learning, I believe. Like, so machine learning, there's so many different algorithms for data imaging which can be used to build the systems. And essentially, they're nothing but read your past data and predict your future. And essentially, like there are so many different algorithms which comes part of a machine learning, which we'll look into later, right? But machine learning nothing but focuses basically on, something where the system learns it by itself and keeps growing it itself, where it's something is what you call it as artificial intelligence, right? And when a new data is exposed, it knows what to do because it has trained itself based on the past, right? So you take your training data, apply the algorithm, and build the model. That's what you do. And in general, machine learnings are classified into two, right? In terms of learning. One is your supervised learning and unsupervised learning. So supervised learning is where you have a known data set, right? Where there are labels, and simple as that, right? So where, for example, when I say, when I have a cream, right? And I say this cream is chocolate. Tomorrow is and I say it's in this color, etc., etc. So you come up with a new cream altogether tomorrow, and based on what it looks into, right, from the past, it understood from what it is, it can tell what this cream is, right? And because you said what this cream was and how it looks, and that is what you call it as supervised learning, right? So they are nothing but a known data set to make predictions. Training data set includes input data and the response value. So when you train the machine, you already give the information as to what this is, the response value also. So from it, the supervised learning algorithm builds a model to make predictions of the response value for a new data set. When it comes to unsupervised learning, it draws inference from the data set based on certain patterns within that, right? Certain the way the data looks like. So it's used for exploratory data analysis, wherein you would be able to find some hidden patterns or groups within the data, right? So the most common unsupervised learning method is a cluster analysis, right? Where you kind of group things, right? You cluster, put people into certain bucket. For example, high income, low income, right? So when you have a data of all the people who are earning, right? So you just take the data and you understand the pattern within that, right? The hidden patterns within that, and you start bucketing them. So that's basically is unsupervised learning, and that's what that algorithm does, and specifically the cluster does as well. Again, this is a list where it is not a full list, not a complete list. It's just a small snippet, you can call it as. When it comes to supervised learning and unsupervised learning and machine learning, some of the techniques which are used, right? Navy bias is very popular in terms of spam filtering. Even Google uses it, right? And every spam filter in the world uses Navy bias, which is lazy techniques you can call. There's SVMs, which is where Netflix is used in recommendation engine. Random forest and decision trees are classification examples. K-means clustering, fussy, hierarchical, all part of your clustering analysis techniques as such, right? Now, let's run into quickly and demo, right? Wherein I demonstrate, how to do a sentimental analysis, right? And we take an example of Zomato ratings review, right? And we'll let's quickly look into it. And before that, this is the as you know, this is a webinar. The actual course from the Edureka involves all this. There are 9 modules which are involved, which takes you away the journey from the introduction of your data science, getting more to learn about the data and how do you manipulate the data, and more of machine learning techniques, right? You will be learning about how to do clusterings, all those things which you looked at, right? So clusterings and supervised learning, unsupervised learning, and some of the techniques, how you built it, do it through R. We'll learn about Hadoop and Hadoop architecture, and you'll be looking into how R and Hadoop are integrated together, and how and also how Mahout is built and all that. So that's what the entire data science course is packed up with in the Edureka courses and concerned, right? And yeah, and there's a final project which earns you that certification as such, right? So now let's look into the demo quickly about the movie rating. And so as far as the data is concerned, this is the data which we are looking at. So it has all the location, restaurant, and the comments by the in the website. Whatever the comments given by the the moviegoers and all that. So now essentially what we're trying to do is we're trying to I mean this rather like a restaurant, not sorry, not the movie, rather the comments given for the restaurant. And what we're trying to do is do a sentiment analysis of all this unstructured data as such, right? So that's essentially what we're trying to do here. So essentially, this is the structure of the data, right? All of these are factors, and finally, this is where your unstructured data is, right? And so we have the positive and negative, data as such with this, right? So and we are loading the positive and negative dictionary, so to speak, right? The positive and negative dictionaries, and then we are identifying the polarization of these words, positive and the negative, right? And then essentially, we are writing our own function here. This is the function which essentially identifies the sentiment over the unstructured data, right? Based on the dictionary what we did, right? So so we're creating a vector, and then we're going through every words, right? And based on every words, based on the dictionary, knowing what is the the sentiment polarization for that, we are actually scoring them as such, right? For the entire data, right? So for the entire data, we are actually performing for the entire data what we saw, for all this, we are performing the sentiment as such, right? And once we are done with the sentiment scoring, right? Now what we are doing is we are visualizing it, right? So something. Okay, sorry about it. So it's just, when the entire thing was done, it didn't source. So you can see that the sentiment scores are done for everything in the data, right? So we're talking about 175 observations. For all of 175 observations, we have the sentiment scored for all those who were in the restaurant and who have actually provided their feedback. And we're trying to visualize it, right? As I said, it's a great visualization. We are just using a very standard visualization here. So what we're looking at is a simple histogram from the entire data set, right? So we're looking at the entire population. So we're talking about out of 175 customers, close to near about 100 customers falls within the range of 0 to 5, right? So that's close to they're fairly positive, or rather like you can call it as neutral. It depends upon what the scales are, right? And also we can look at it in a tabular format, right? And this is what we are actually looking at in terms of a tabular format from the scale of -5 to 27. So you can see like a lot of them, as we know, right, between 0 to 5 is what say, like a lot of them fall within this range, that 100, right? So the same thing, visualizing, also looking in a tabular format. So this is an example of sentiment analysis using the R tool, where we process the data, applied an algorithm to it, and also visualized it. Okay. Now let's take up the questions, whatever people had here, right? Okay. So starting from the question with, I think, JSON. Yeah. Oh, sorry. With I think I'm done with JSON. I'm going to start with uh, Yaneshwar. I'm working in a Java J2E from 6 years. Can I have data science as my career from here onwards? Absolutely. You can have your career at any point of time. There's nothing like, about me, like have 15 years of experience, and I've been doing data science for the last 5 years out of it. So if I put that into the picture, I started my career of data science from the 11th year onwards. So so you can consider that I've been working on the data engineering, advanced computing, and as such now, and of course various domain knowledge. Now I fulfilled the rest of the other parts, which is basically my statistical and also the visualizations as well, actually, right? So there's rather I would say it's good now rather than later, right? Are we So Jason asked, what are the major analytics used? But there's so many techniques, but when it comes to machine learning is what we actually looked into now. People turn into clusterings when it comes to customer segmentation, when it comes to movie ratings and all those things. They look into recommender systems, right? Netflix, Amazon. You can see all the Amazon's recommendations all use the same recommendation, and they use apropy algorithm. And the other words, they call it as market basket analysis. That's a technique which is used, fundamentally used thing. And chi-square is JSON is like, it's a basic, so to speak. The chi-square itself was used to build something called shade analysis, is where it is used in terms of predictions, where and more of it's an algorithm which is actually used where you can also give a very descriptive information, right? Where when people use a logistic regression, right? Where you say whether this person is going to buy this or not, right? Churn or he's going to churn or not churn. Same way you can use shade analysis to tell whether he's going to churn or not, and at the same time why you think he's going to churn, right? Because that's what it is. So there's so many different algorithms for so many different business cases or uses. So that's why a knowledge of statistical techniques and mathematical techniques and all that will be able to help you to derive. And again, a pure quantitative techniques, or a guy who's a data scientist who's more into the statistics and all that will even build his own algorithm, so to speak, right? And a guy who's very, very, very advanced, so to speak. Would transformation also involve? Oh, I answered this question, Manish. Can we embed the scripting language like Python for data extraction from social media in R? Yeah, I answered it, yes. And can we integrate R with Hadoop, HDFS, Hive Space? I think we just saw it. You have R-Hadoop from Revolution Analytics, and yes, pretty much, yes, you can do that, right? And so for Hive, even you can just use a simple RODBC. You don't even need anything like R-Hive or anything like that. An ODBC within the R is more than enough to pull data from Hive, actually, right? I'm doing research on machine learning. Which book material you recommend for that? How do I be expert in machine learning? Which are maybe the steps I should follow? Okay, see, some of the things which helps you to become a data scientist or even get into the machine learning and all that. As I said, there's so many different books, starting from Introduction to Statistical Learning, ISL you call it as, and again you have so many books in machine learning, and in addition to that, actually, I would recommend you to take, like also look into Coursera's, or at the same time look into register yourself in Kaggle contest and start looking into many of the things and start learning that as such. And there is a site called statistics.com. Again, they have extensive thing. And of course, Harvard and Stanford all has their, CS courses, which again, helps in in-depth learning of machine learning, right? As such, when it comes to your thesis, PhDs, and all those things as such. And how analytics is different from statistics. Now, see, right, the analytics are nothing but is basically your end result, right? And what happens is you use certain techniques, right? And that techniques is nothing but statistics or any mathematical, right? So analysis is what you do, right? Analytics are nothing but analysis, right? What do you how do you do analysis? You apply certain techniques such as statistics, using such as machine learning rather, right? Such as machine learnings or artificial intelligence or certain algorithms such as whatever we spoke. So analytics is the process, so to speak, right? And statistics are the techniques, are the methods which are used basically, right? And Deep, I think we showed some R code. And this is a webinar, mind you. So, and I believe you would be, happy that at the end of the thing, it was not just a theoretical session. It was there was a demonstration of the R code. And I think we mentioned it in the earlier, right? And what we did was a sentimental analysis on a unstructured data, right? I know only R programming and data science, machine learning, plus machine learning. So whether Hadoop knowing is necessary, can I join industrially with R data science plus machine learning? Well, Hadoop is necessary, yes, because we're talking about uh, you know looking at vast amount of data and deriving something. So looking at just data where few rest, I may say for example, right, you're trying to build, that is where you're as like we looked at in the slide and where we said an algorithm is good only when there is more data, right? So let's say you are trying to apply a market basket analysis to build a recommendation system, right? Your recommendation system is not going to be good or efficient until or unless you look at the data in the whole entire world and analyze many different factors and put it into it to and build your model and evaluate it. So yes, knowing learning Hadoop is important in this data science world. And what does it do in the Hadoop world? You will store the data and extract the data and transform this data. All these three things you would do in the Hadoop world. And you can write algorithms in machine learning in Yanesh in R, Python, Julia, and even you can do it in Java, but it's going to be very complex, Scala, and all those things. Do I want to know the list of companies having opportunities? Unfortunately, I can't provide it, Kanti. Like there are so many. You can go to any portal, job portal. There's so many companies. Search for data science, analytics, big data, and everything is an opportunity. What algorithm was applied here in sentiment analysis? You wrote your own function here. Uh, all you did was you wrote your own function, and that's all you did here. But again, you can also use techniques such as naive bias to do it. But we are just showing that it's limitless. You can do anything you want. But in this case, there were no specific algorithm was used. It was simply built on three things. One is you had a dictionary of positive and negative words, and you wrote your own function to look into every single word and look into the polarization and score it. Okay, so that is what you did here in this case, right? And which university do you recommend best for data science? That depends upon what money you can put. If you are in India, IIM has it, and ISB has it. So if you can shell off some good amount of money, you can get it from these two universities. And there's a institute at Hyderabad called NSOFE, If you're in abroad, like the US, of course, Stanford has it, Harvard has it, Northwestern University has it. In fact, for that matter, you can even do your masters in predictive science, masters in big data, and all that actually. Pretty much in abroad, every university starts to build it as part of their, as I said, education, regular day-to-day curriculum. Such. How to use the sentiment scores to demand forecasting in retail? As I said, yes, you can use the sentiment scores and you can use your market basket analysis or APROP and all that. It'll be a combination of more than one techniques together, right? So that's where, if you remember, when we looked in the data science thing, right? And when you transform this data and you look for the pattern, so with the data science, with this sentiment analysis, you see some pattern. Then you can essentially, as we saw that 0 to 50, 0 to 5, we saw people were clustered in that particular group. You can just take them as a sample, right? You take that as a sample, and which are positive customers, and you group the rest others into some others. So essentially you do the clustering over there, and then you can start applying a predictive algorithms. It could be anything, right? And here, in terms of demanding your forecasting, here you can use your time series. So now the same thing, how it is over a period of time, and you build using you use ARIMA, right? Auto regression in moving average, and then you can do a forecasting on that, right? So in terms of forecasting all that, you can build time series analysis, and you can do that, right? Tbrush, that will be the best way to do it in this particular scenario. What is the difference between business analytics and data analytics? There are so many different names, right? They one another mean the same. At the end of the day, even a business analysis guy or a data analysis guy are going to look into data, and essentially he's going to do all those things which we looked into the past of the KDD. Okay. Hadoop's role is just to store the data. Rest are all done through analytics tools such as SAS or nowadays SAS are also like pulls data from like Hadoop. Hadoop role is Hadoop is storage, yes, and also for ELT, not ETL, extraction, load, transformation. Hadoop is more a ELT. Okay. I have same question at an experience level now looking to break into data science career. I think I've answered it. At any point of time in your career, you can break through and get into this. So you would be using your past and present actually, right? So I'm skipping few of the questions which are repeated, which I have already answered. Can you repeat the statistics book related with stat book I should follow? You can go with there are many statistics book. Preliminary, you can start with this guy is who's this the O'Reilly has a book, right? Data analysis, and there is this what is this O'Reilly book with how it has all these images, right? They have this Headfirst has this book on data analytics, right? On statistics. That's a great book to start with, great book online. And there's a great book called, if you are interested in the way what is taught in the university, there's a book called Data and Models. And the best book I would also recommend is ISL, Introduction to Statistical Learning. It's a great book to start with as well, right? Believe training is not enough to grab data science. Can Edureka help to students to do 10 projects? Well, see, I mean, more and more practice makes you perfect, right? So essentially, all this, whatever you learn, it's going to be a pinch of salt, and you need to learn a lot. I think I have another picture here to help you up, show you. It's a journey for that matter, right? Just I mean, we're running out of time, but essentially, like just go and Google it and search for data science journey, and you would see more like a like a train map, right? Train journey map, and you can see like there is a like 10 journeys, 10 steps which you have to take it to do it actually. For data science, what ecosystems of Hadoop is required? Is MapReduce is no, MapReduce is not enough. You can do data science is big. You can do data science in Hive. Not the complete data science as to building algorithm, but even for that matter, ngram is a data science for that matter, right? Working on unstructured, you can do it in HBase. There is the solar where you can essentially do searching, right? Where it has LDA and LSA and kind of things. There is, and like there are other things within the Hadoop ecosystems nowadays, like Mahout, MLlib, all these are ecosystems, right? But for machine learning though, is you will have yes, Vishwa, this is recorded and it will be available in 24 hours time. Why R, why not SAS? Simple. SAS is commercial, licensed, and there are so many different things. R is open source, and it has all the latest algorithms and techniques, right? And SAS takes a lot of time for certain algorithms to be released as such. What may be the salary for data scientists at beginning level with PhD in computer science? Depends, right? I can give you anywhere from, there are people whom I know even earning 200 to 250K. There are people who are earning even 100K. So it depends. It's all your negotiation skills, I would say. Was a directory created using LDAP? I'm not sure which. Oh, was a dictionary created using LDAP? No, it was not. I think it was openly available. There are a lot of dictionaries which are available in the in the internet which you can use for the negative and positive. You have it from the Stanford library as well. Can R load data from Oracle? Yes. As I said, there is something called ODBC. R ODBC, you can use it and load it from anywhere, MySQL, Oracle, whatever it is. How are Cloudera certificate professional data science compared to Edureka course? Is it comparable or can one of them be termed as a stepstone to other? This is a stepstone to that, but essentially, say for example, it's a combination of many. Like if you take the Hadoop course from Edureka and your data this course from Edureka, all this would help you. And additionally, you need lot. For example, Cloudera certified, you need to read through the Hadoop Definite Guide 4th edition book, right? And essentially, walk through many of the ecosystems which are there, practical, and then that helps you to, get you that. I'm in verge of completing PhD specialization in machine learning. Want to join companies also acting as assistant professor. Salary expectation with LBD. Please tell me I'm earning 60 per month. Will it be more? Yes, of course. I think you're the very much of a basic level, and again, a bit of experience. Few, as I said, Kaggle contest, etc., and negotiation. You can do more. And Oracle shows down while handling a large data set. How R can be fed data by Oracle? One would be very slow. Yes, that's why you need Hadoop, right? And so that's where you can actually break down the latency, right? Because R itself is an in-memory. That is why you also need the revolution analytics so that it can be parallelized. Okay. Okay, so we're running out of, we ran out of time. I won't be able to take more questions, unfortunately. I'm just taking one last question from Prasanna. What is the scope of doing an MS in Business Intelligence Analytics? I thought I answered something. Scope is very high. Do it now. That's what I would say, right? And it is great even if you are working, so that you can put it both things together. And I think it's a USP which you would have in the corporate world. And thank you everyone. I hope you enjoyed the session. And this is just a pinch of salt of what you can, and there is more to it. And whatever it is, practice, and read. That's how you can actually, like not one class, one session at all can, teach you everything. So take this a pinch of salt and start doing that. Bye bye.